Now, say in this question, a circular track of radius 400 meter is banked at an angle of 10 degree. If mu between wheel of the car and road is 0.2, what is the optimum speed of the car to avoid wear and tear on its tire and maximum permissible speed to avoid slipping? Now, see here, you have done this formula. V maximum is equal to under root of Rg mu plus tan theta upon 1 minus mu tan theta. We have derived the formula in the previous topics. This is the maximum permissible speed when the car is moving on the banked road. Now, for the first case, optimum speed of the car to avoid wear and tear. If the frictional force is almost 0, mu s is 0 coefficient of friction, then there is almost no wear and tear. So, first part, if you are taking here mu s is equal to 0, then you will be getting V is equal to under root of Rg tan theta. Now, put the value of R, that is radius is given to you 400 meter, under root of 400 into G you can take 9.8 and tan theta, that is tan 10 degree, that is given to you 0.1763, and this is coming around 26.29 meter per second. So, this is the speed, optimum speed when there is no wear and tear on the tire. In the second case, maximum permissible speed to avoid slipping. If you have taken the maximum permissible speed with the frictional force, with the coefficient of friction, so you have to use this formula. V max is equal to under root of 400 into 9.8 into, that is 0.2 plus 0.1763 divided by 1 minus 0.2 into 0.1763. Now, if you solve this value, you will be getting the answer around 39.10 meter per second on solving this. So, this is the maximum permissible speed to avoid slipping.